Great viewers, let's check this question on trigonometry, identities. It says show that sine squared theta plus cos squared theta equal to 1. Also show that 1 plus tan squared theta equals to sec squared theta. And cot squared theta plus 1 equal to cosec squared theta. All right. So before we go into the proof, we need to show the trig ratio of sine theta, cos theta, tan theta, cosec, sec, and cotangent. Right? So go with me. So let's go. Solution. So the first thing you do, draw a right angle triangle. Okay? Here, label it. Let's label here to be C. Label here to be B. And here to be A. This is an acute angle. Okay? All right. Now, first of all, let's recall our SOHCAHTOA trig ratio. Trig ratio, SOHCAHTOA. All right. So let's recall it. SOHCAHTOA, this one means that sine theta is opposite over hypotenuse. So that means that where is our opposite is B, opposite the angle. This is the opposite. So it's B over, what is this one? Adjacent. We have C. This is hypotenuse. Right? So the next is cos theta is what? Adjacent over what? Hypotenuse. Okay? Adjacent is A and hypotenuse is what? C. So the next is tan theta, which is opposite over adjacent. As you can see, opposite over adjacent. Opposite is B over A. All right. So with this in mind, let's get sec theta. This is seen as 1 over cos what? Theta. Okay? Inverse. So the inverse of cos theta is C over A. The inverse, which is what? Hypotenuse over adjacent, C over A. Then we have cosec theta. This is 1 over sine theta. The inverse of sine theta is what? C over B. Okay. Then cot theta, that is cotangent. We have 1 over tan theta. So this one will be what? Tangent is also, the inverse is what? B over, that is A inverse, A over B. Okay. All right, so we've gotten these values. So the next thing we do for us to get our proof, all right? So let's progress. To get our proof, we move. First one, proof. So you write, by Pythagoras theorem, so we want to apply Pythagoras theorem to this, which states that what? The square of the hypotenuse is equal to the square of B plus the square of what? A. So you have a hypotenuse square equals to opposite square plus adjacent square. So this is from Pythagoras theorem. All right. Now, the next thing you do is divide both sides by C square. Divide both sides by C square. So that you have a numerator and a denominator. So when you divide by C square, you have a C square over C square equals to B square over C square plus A square over c square. All right? So this one now will be, this will go with this. You have 1 equal to. All right. Now, let's check. B square, B over C is what? B over C is sine. So you have what? Okay, let me progress. You have B over C all square plus A over C all square. Because they have the same power. So it can be written like this from indices. Okay? All right. So let's go. So here now you have 1 is equal to B over C is what? Sine. So you have sine, because of the square, you have square theta. All right? This is sine theta all square plus the A over C is cos theta. I have cos of the square, cos square theta. Right? Proven. Okay? So it can be written, because addition is commutative, so it can be written sine square theta plus cos square theta equal to 1. All right. Okay, so we've done the first one. Now, the second one. Let's call this one 1. Right? So you say divide 1 by sine square theta. So if you do that, you have sine square theta, okay, divided by sine square theta plus cos square theta divided by sine square theta equal to 1 over sine square theta. So this one goes off, you have 1 plus cos square theta divided by sine square theta will give us what? Let's see what goes there for us. It gives us cotan. Cotan. This will give you cot square theta. Cos square theta over sine square theta is what? Cot. That is A over B. Because when you divide cosine by sine, you get A over B, which is cot. So this is cos square theta. 1 over sine theta is what? 1 over sine theta is cosec. So you have cosec square theta. So we've gotten number 3. Number 3. This is number 3 from our proof. Okay? So you can arrange it. It becomes what? Cot square theta plus 1 equals to cosec square theta. There's no change. All right. So let's go. So we can still prove the other one. How do we do that? Divide equation 1 by cos square theta. Just a simple logic, right? So you have, when you divide now, by dividing this, you have sine square theta all over cos square theta plus cos square theta all over cos square theta equal to 1 over cos square theta. Okay? So this will go off, all right? So we have sine square theta, sine theta over cos theta is tangent, is tan. So you have here tan, sine theta over cos theta is tan. So you have tan square theta because of the square plus 1. 1 over cos theta, 1 over cos theta, that is sec. So have sec square theta, all right? So this one now, you've been able to show that 1 plus tan square theta is equals to sec square theta. This is number 2 of it. Right. So go through it. It's a very simple one. So if you run through it, you find out that it's a very easy one. Okay? It's a very easy one. So this is how you derive those trigonometrical identities. So with these identities with you, you can prove any other identity. So keep this in mind, keep this in mind, keep cot theta as cosine theta over sine theta. Then know these ones. When you have all this in your mind, there's no trigonometry identity that you can't prove. Okay? So go through them. If you have any issue, drop it at the comment section. See you in the next video. Thank you.